There she is, daredevil pilot Natalie Haymaker, ready to try for a new world's record.
That's right. I'm going to break the record for an around-the-world flight over the poles. The record is 54 hours. I'm going to do it in 48. Here's what my path will look like. I'm going to start out here at a place on the equator. That's this imaginary line drawn east and west all the way around the Earth. It's halfway between the North Pole and the South Pole. I'll take off going directly south, pass over the South Pole, and continue flying around this side of the Earth to the North Pole. Then I'll fly south on this side of the Earth and end up at the equator where I started. My clock will keep track of the time, and my mileage counter will show the distance I've traveled. There are certain tracking stations along the way, and I have to signal with a laser beam as I pass over them. That'll prove I was there. My navigator knows where they are.
I can see that you're ready to take off now, except for your navigator, who just needs to wake up. But wait, your navigator's not on board.
What? He's not on the airplane? But I need him. He has the places marked on his map where the stations are.
Could I help?
Can you navigate?
Well, I can help you navigate. I don't have a map, but here are the locations of the tracking stations. Station 1, 45 degrees south latitude. Station 2, 90 degrees south latitude. Station 3, 30 degrees north latitude. Station 4, 90 degrees north latitude. Station 5, 45 degrees north latitude.
This doesn't tell me anything that helps. I know what north and south mean, but what do they mean here?
They tell you whether the stations are north or south of the equator.
Oh, so 3 of them are north of the equator, and 2 of them are south of the equator.
That's right.
And what's this? Latitude.
Latitude tells you how far north or south of the equator the places are.
But those measurements are in degrees. How can degrees tell me how far something is?
Whenever you measure anything, you need units to measure with. If you're measuring distances from the equator, you're really measuring on a circle, on your flight path, for instance. And to measure on a circle, you divide it into equal units, 360 of them. Each unit is called a degree, in this case, a degree of latitude.
So degrees of latitude are the units used to measure distances north and south of the equator.
That's right. To make it simple, we'll just mark some of these degrees. Let's bring the Earth back on again. Now, if we let the Earth spin on its axis and mark the paths formed as the Earth passes under each of these points, we'll make these lines. All points on each line are at the same latitude. This line is the equator. Every point on it is at 0 degrees. All points on this line are at 15 degrees latitude north of the equator, or 15 degrees north latitude. Every place on this line is at 30 degrees north latitude, and so on. The North Pole is at 90 degrees north latitude.
Does it work the same way south of the equator? Are all points on this line at 15 degrees south latitude, and every point on this line at 30 degrees south latitude, and so on? And is the South Pole at 90 degrees south latitude?
Exactly right. These are all latitude lines, or parallels of latitude. They're called that because from this point of view, the lines look straight and parallel. But if you could see them from above the North Pole, you'd see that they're really circles. You use them to find out how far from the equator you are, north or south. Just remember that all points on any parallel of latitude are the same distance from the equator.
This says the first station is at 45 degrees south latitude. So I just look out the window, and when I see the 45-degree line, I flash my laser beam, right?
Well, locating parallels of latitude isn't quite that simple. Like the equator, they're not really drawn on the Earth.
What good can they do if they're not really on the Earth? How can I use them?
Here's one way. You can translate distance in degrees into distance in miles or kilometers.
Oh, I think I see how. Could you tell me how far it is all the way around the world through the poles?
About 25,000 miles.
And I know there are 360 degrees all the way around the world. So if I divide, I can see that each degree of latitude must represent a little over 69 miles. I started at 0 degrees, and I want to send my first signal at 45 degrees south latitude, which means the first leg of my record-setting trip is 45 degrees long. That's 45 times a little over 69 miles for each degree, or about 3,125 miles. My mileage counter was at 0 when I left the equator, and now it's at 3,121 miles. I must be almost there.
Exactly right.
3,123, 3,124, 3,125. I'm there now. I'll flash my laser beam. That was easy. Looks like a nice day down there. Not as hot as at the equator. Now I've got to keep moving if I want to break the record.
Will you have any trouble finding the next station?
No, it'll be simple. 90 degrees south latitude. That's the South Pole. Each time I flash my laser beam, my mileage counter automatically resets to 0. So it reset itself at 45 degrees south latitude after I'd gone 3,125 miles. Now to get to 90 degrees south latitude, I'm going 45 more degrees. So that must be another 3,125 miles. Now there are 3 miles to go, 2 miles, 1 mile. I'm at 90 degrees now. And it's taken me exactly 12 hours to go a quarter of the way around the world. I'm right on schedule. Sure looks cold down there. A lot colder than it was back at 45 degrees south.
Well, the South Pole is as far as you can get south. The farther you get from the equator, the colder it usually gets.
Why is that?
Well, remember, it's the energy and the light from the sun that heats the Earth. For the moment, let's think about just this much of the light. When this amount of sunlight strikes the Earth here, it heats only a small area on the Earth, so it can heat that area quite a lot. Any spot within that area gets pretty warm. But because the Earth has a curved surface, like the surface of a ball, when the same amount of light strikes here, it's spread out over a much larger area.
So any spot within that area gets a lot less heat.
Exactly. So as you go from the equator to a pole, temperatures usually get colder and colder.
I see. The next station is at 30 degrees north latitude. That's 120 degrees from the last station at the South Pole. So that will be 120 times a little over 69 miles for each degree, or about 8,333 miles. My mileage counter says I'm coming up on that fast. 8,331, 8,332, 8,333. I must be at 30 degrees north latitude now. Nice and warm down there.
Well, it's only 30 degrees of latitude from the equator, so you'd expect it to be warm there. But your next place to signal is as far north of the equator as you can get.
I know, 90 degrees north. That's the North Pole. Let's see, I'm at 30 degrees north now. To get to 90 degrees north, I have to go 60 more degrees. About 4,166 miles. And there it is, the North Pole. It's frozen like the other pole. It's only been 36 hours since I left home, so I'm right on schedule. At this rate, I'll break the record by 9 hours.
You've only got one more tracking station to signal before you head back to the equator. It's at 45 degrees north latitude.
That's 45 degrees south of the pole, only 3,125 miles. I'm almost there. And now I've only been gone 42 hours. I'm there now. Oh no, my wings are icing up. I'm losing altitude. I'll have to land and turn on my de-icer. Oh, I had a good chance of breaking the record. Hey, there's snow all around. At 45 degrees south latitude at the first station, it was a summer day. And here it looks like the middle of winter.
Well, it is the middle of winter here. That's because when it's summer in the southern hemisphere, where 45 degrees south latitude is, it's winter in the northern hemisphere, where 45 degrees north latitude is.
But both parallels of latitude are 45 degrees from the equator. Why is it summer at one of them and winter at the other?
To see, let's look at the Earth again. You may have noticed that the Earth's axis doesn't go exactly straight up and down. The Earth and its axis are tilted quite a lot to one side, and it's because of this tilt that the Earth has seasons. This is how it works. As you probably know, the Earth revolves around the sun once a year. As it does this, the tilt of the Earth's axis doesn't change. So when the Earth is in, say, this position in its path around the sun, light from the sun strikes the Earth from this direction, like this. The most direct sunlight is here, above the equator in the northern hemisphere.
That makes the northern hemisphere warmer, doesn't it? So then, is it summer in the northern hemisphere and winter in the southern hemisphere?
Exactly right. But remember, the Earth keeps revolving around the sun. So half a year later, the Earth is here in its path, and light from the sun strikes it from this direction, like this. The Earth is still tilted the same way, so then the most direct sunlight falls here, below the equator in the southern hemisphere.
And then it's summer there, isn't it? And winter in the northern hemisphere. That must be the position the Earth is in about now, because it sure is winter here at 45 degrees north latitude. Does that mean it's winter in the whole northern hemisphere?
No. If you think about the Earth and the sun, you can probably make a pretty good guess about what parts of the Earth are having winter now. When the sunlight comes from this direction, you can see that this part of the Earth would generally be pretty warm. And when the Earth has revolved into this position half a year later, and sunlight hits the Earth from this direction, a large part of that region is still warm. So this area, from about 25 degrees south latitude to about 25 degrees north latitude,
is pretty much warm all year.
That's right. And you can see that whether the sunlight comes from this direction or this direction, these two regions around the two poles always get their sunlight spread out over a large area.
So the regions around the poles never really warm up.
Right. They have short, cool summers and long, cold winters.
Well, if these parts are always pretty cold, and if this part is usually pretty warm, it must be these areas in between that have seasons. I mean seasons with big differences in temperature, warm summers and cold winters.
Correct.
I see. So it's winter now in this part of the Earth where I am, and this part is having summer. And in 6 months, this part of the Earth will be having winter, while this part has summer.
Exactly right, and all because the tilt of the Earth's axis remains the same as the Earth revolves around the sun.
Look, my wings aren't iced up anymore. I can take off again.
You only lost 2 hours. You've been traveling 44 hours. Now you just need to get back to the equator where you started in less than 10 hours, and you've beaten the 54-hour record.
I can do it in 6. Thanks for helping me understand latitude, so I could break the record for a trip around the world over both poles.